Hello viewers, I am Sunil Kumar. Today I am going to present a lecture on benzoin condensation. So benzoin condensation is a nucleophilic reaction involving 2 moles of aromatic aldehydes in the presence of cyanide ion as a catalyst in aqueous alcoholic conditions, giving alpha hydroxy-ketones, or that is also called as benzoins. So we can very easily see we have 2 moles of aldehydes. One is acting as a donor, second is acting as an acceptor. Catalyst is the cyanide ion, medium is aqueous alcoholic solution. And the product is the benzoin, that is hydroxy-ketones. Well, so this is very important CC bond forming reaction. Other important reactions being like aldol condensation. The reaction is based on Ampoulang concept. What is Ampoulang? That is the reversal of polarity. That will explain in detail in the mechanism. Then traditionally it was the cyanide, but more recently it is catalyzed by coenzymes or N-heterocyclic carbenes, NHCs. Most importantly, this is a reversible reaction. Relative thermodynamic stability of the product and starting material decides the product ratio. In fact, in our body also there occurs a benzoin condensation, which is catalyzed by thiazolium moiety. For example, decarboxylation of pyruvate occurs in the presence of thiazolium moiety in the body itself. That is kind of benzoin condensation, though that does not involve any cyanide ion as such. Sometimes it is called as acylene condensation to encompass reactions of aliphatic aldehyde. So after this we have to move on to mechanism, that is very important. Now this reaction begins with the first mole of benzaldehyde, in which the cyanide ion, in terms of either potassium cyanide or sodium cyanide, attacks this carbonyl carbon. Why this carbonyl carbon? Because this is electron deficient nature, because it is attached to oxygen atom here, which is electronegative, so it pulls the electron density towards itself. So this carbon has partial positive character, here partial negative character. So when attack happens, then cyanohydrin anion is formed. See, here it is cyanide, here O minus, here H. Now these moieties are called as acyl anion equivalent. Now beauty of this cyanohydrin anion is that here cyanide is attached, which is strongly electron withdrawing in nature. So it pulls the electron density from this carbon. Now because of that, the proton attached to this carbon becomes highly acidic in nature. So that can very easily be removed. When this proton is removed, that is, there is proton shift. So carbon having negative charge, that is a nucleophilic carbon, is formed. So proton comes here, so it becomes OH. And here it is C minus, that is nucleophilic carbon. What is the driving force for this particular step? So the driving force being that this intermediate, this nucleophilic carbanion itself is stabilized by resonance. Just see the nucleophilic carbon attacking here, double bond, this comes here. So this is nitrile enolate, C double bond N minus. So hence this acquires stability. So this is the driving force over here. Now in the introduction I told you there is a concept called as Ampoulang. So what exactly the Ampoulang is? So Ampoulang is that when there is reversal of polarity from, here you can see there is partial positive charge, but here there is formal negative charge. So when there is reversal of the polarity from positive to negative, this concept is termed as Ampoulang concept. This kind of reversal of polarity wherein the carbonyl carbon is having negative charge is hardly witnessed in the organic reactions. This is one of the few exceptions. Now the further step is that this carbanion, the nucleophilic carbon, now attacks the second mole of aldehyde, which is obviously this carbon is electrophilic in nature as was here. So electron coming here, so these electrons migrating towards oxygen, oxygen acquiring a negative charge. So you can see oxygen acquiring negative charge. Now immediately there is a proton shift. So this proton, it comes here and it becomes negatively charged. So their reaction is very fast and instantaneously this O minus gives the electron to this oxygen carbon bond and cyanide is removed. Here cyanide is lost. And we get a product PH, C double bond O, CH, OH and then pH. PH, CO, CHOH and pH. Such structures they are called as benzoins. So you will find that this reaction throughout there is role of cyanide. So that first it is nucleophile. It is acting as a nucleophile because see this is having very high polarizability. Potassium cyanide, sodium cyanide, and plus since it is very small nucleophile, it does not create much steric hindrance to this particular attack. It can very easily attack this carbonyl carbon. So that is why this is a very good nucleophile. Second, it is electron withdrawing in nature. See here, it was electron withdrawing in nature. So it is abstracting the electron from this carbon so that this proton becomes highly acidic in nature. So that can be very easily lost. So it becomes negatively charged over here. Thirdly, it stabilizes the carbanion. You can see this particular step. Now this carbanion generated gets stabilized just because there is this cyanide structure. Had it been no cyanide, we would not have witnessed the stabilization of this carbanion ion and maybe the reaction would not have been possible over here. Next is the leaving group. Now if you move further, in this step, cyanide can be lost very easily. So this is acting as a very good leaving group. But there is some risk associated with this. What is that risk? That we'll see in some other slide. Let's have the glimpses of some examples. The first being, which of the following undergoes benzoin condensation? We have 1, 2, 3 examples and it can be all the 3. So I would like you all to take a pause, think and guess the answer. So let's move ahead. Correct answer being answer A, because aromatic aldehydes having very strong plus I or minus I do not give this reaction. Remember, in all the cases, here we have 2 moles of this aldehyde or this aldehyde or this aldehyde, but only this gives the benzoin condensation while these two do not give. Because they have this strong nitro group which is acting as minus I or methyl groups attached to nitrogen that is acting as plus I. So the answer lies in step 1 of the mechanism. So let's see what step 1 of the mechanism is. See, herein we find that this group is attacking this carbonyl carbon, electron is moving like this, the way we saw all the other mechanisms, and this is how this cyanohydrin is going to be formed, and this is carbanion. If we see very carefully, since nitro pulls the electron density towards itself, so the nucleophilicity of this carbon decreases very much. this carbanion is no more nucleophilic in nature, so that it cannot attack the second mole of this same unit, right? Now let's see amino group, dimethyl amino group. Herein, now this cyanide attacks this carbonyl carbon, and then electron coming towards oxygen. Now important point is that in this case, this because of nitrogen attached to two methyl groups, the electron donation tendency increases very much. But as far as second part is concerned, that removal of this, that is transfer of this to oxygen, this reaction is very difficult because this carbon itself becomes electron rich in center. The acidity of this proton decreases very much, so it cannot depart so easily. So that is why this carbanion is not generated. So that is the reason this reaction also does not take place. Now let's see the third one. Now let's take furfuran. Herein, the nucleophile will attack this carbon, will get cyanohydrin anion. Now subsequently carbanion is generated, and which can attack the carbonyl carbon, and we can get furan. Earlier we took 2 moles of this and we tried to saw that what is going to be the product. We could not get the product, but now we have changed the rules slightly. We have mixed the two. Now what we are finding, let's take with one example. In case of furfural, we have two possibilities. Either cyanide is attacking this carbonyl carbon, or it is attacking this carbonyl carbon. Now we just saw that when cyanide attacks here, the subsequent carbanion generation is stopped because the plus I impact of this stops the further reaction. But when cyanide attacks here, the nucleophile generated can attack this carbonyl carbon, though the yield of the product will be slightly lower. Definitely it will be. So we can expect this product out of the condensation between these two aldehydes. So one aldehyde is different, second aldehyde is different. So such kind of reactions wherein we have different aldehydes are called as mixed or crossed benzoin condensation, right? So crossed, here I am giving the third example, PHCHO and PHCOCH3. What is going to be the product that you have to tell me?